Hello, thank you for watching this video. So in this video we're doing question 8 of May, June 2023, question paper Mathematics paper 2. The topic is trig application, the 3D application of trigonometry. So I've tried to draw this diagram here. As you might see, it has many colors and it might look different from what you can see on the question paper because I use these colors so that it can be easy to see, right? Or show you how to look at it in a most efficient way. Okay, so let's go. In the diagram, A, B, and C are points in the same horizontal plane. D is directly above C. That is, DC is perpendicular to AC, and DC is perpendicular to BC. It is given that angle C between AC and CB is 100 degrees, and angle A between CA and AD is 30 degrees. AD is equal to 20 units and BC is equal to 8 units. Let me read this thing again. In the diagram, A, B, and C are points in the same horizontal plane. It is given that D is directly above C. That is, DC is perpendicular to AC and DC is perpendicular to BC. It is given that angle C between AC and CB is equal to 100 degrees and angle A between CA and AD is equal to 30 degrees. AD is equal to 20 units and BC is equal to 8 units. So let's look at this diagram here. Let's look at it. They're saying A, B, and C are in the same horizontal plane, which means they're in the floor. They're making the floor of this situation here. So you have maybe B here, you have A here, you have B here, you have C here. They're all in the horizontal plane. They're all on the same horizontal surface. Let me say that. A, B, and C are all in the same horizontal surface. Don't look at them, maybe they are slanted like this. No, they're not. They're slanted on the diagram, but in reality, they're all on the horizontal floor like this. That's what they're saying. So you have your B, your A, you have your B, and you have your C here. No problem. They went on to say D is directly above C. You can see D and C is here, right? They're saying C is directly above C. D is directly above C. You can see here's C, there is D. So let me tell you. So I said you have your A, you have your B, and you have your C here, right? So if you have your C here, D is directly above C, is sitting here. Let me try to find a blank page here and see if I'm lucky. Okay, there's no blank page. Let me find a blank page. Okay, so here's the situation. So I will say here there's A, there's B, there's C. Here's the situation. This is the horizontal surface here, as you can see here. But here it doesn't look very horizontal. But they're saying that A, B, and C are in the same horizontal surface, which is they're in a horizontal surface like this one here. I hope it makes sense. So here is your A, here's your B, and here's your C. And then they're saying there's a point D directly above C. So D is somewhere here. So you have these points that are on the floor, right? That form the base of this plane here, of this triangular plane here. D is here, directly above C. That is your D, which is this, your DC, this distance here, DC, is perpendicular to BC. Because you can see, here is AB horizontal, and vertical above you have D. So BC is perpendicular to CD, which is, they form 90 degrees there. So this line BC forms 90 degrees with this one, right? And at the same time, this line DC forms 90 degrees with AC, because you can see, here's your AC, and then there's DC. So there's 90 degrees where they meet at C. That's what they're telling you. And then they went on to say that DA or AD is equal to 20 units. And this length BC is equal to 8 units. Right? Then they went on to say that the angle, which is the angle between angle C on the base, this angle here on the floor, this angle C is equal to 100 degrees, this angle here, angle C, which is, this is the angle between BC and CA. They're saying it's 100 degrees. Here is it. There is it, as you can see there. So this 100 degrees is on this floor, is on the triangle that is on the floor. And then they want them to say that the angle, this angle here, this is the angle of elevation, right? 30 degrees is the angle of elevation. Here is 30 degrees. It's from, because what is the angle of elevation? Angle of elevation is the angle measured from the horizontal up into your line of interest, or your line of sight, or your ray. So this is that we know that we said that AC is horizontal. You can see it. Here is it. Here is it over there. So this angle is measured from the horizontal up into the line of sight, or into the ray that we're interested in, or into the line segment that we're interested in. So that angle is called the angle of elevation, the angle between the horizontal and the line segment of interest. And the line angle of depression is the angle between the horizontal down, which is this angle down here, this angle down here, the angle from the horizontal down to a line of interest. That's the angle of depression. So this 30 degrees is the angle of elevation. Right? No problem. So I think I'm done with the statement here. Right? I said A, B, C. They are all in the flat horizontal surface like this. That's something like this. And then the angle between BC and AC is 100 degrees, as you can see there. No problem. They want them to say that the length BC here, this length here, is 8 units, as you can see there. Then they want them to say the angle, the line segment that is elevated, right? Which is your line segment, or this segment here is 20 units, and the angle of elevation of that line segment is 30 degrees. That's what they're saying. And then they want them to say that your DC is perpendicular to AC, and your DC is perpendicular to your BC. I think I've explained this. Also, what you need to understand and next is that I've used different colors so you can see how many triangles we have here. We have the base triangle. Here is the base triangle. The triangle on the floor, the one that is on the floor, right, is ABC. And you have this triangle here, CDA. This triangle here, the blue one. It's a triangle, the blue one. Here is it. This is the second triangle. You have the third triangle. Here is the third triangle. So this is triangle number 1, right? This is triangle number 2. And here's the triangle number 3. You have 3 triangles that you can see. But there's a fourth one. The fourth one is this one here. The face of this triangle. This triangle over here. Or maybe let me use the same colors so that you can be able to see. This one here, DAB. DAB. The face is also a triangle in its own right. So if you're looking inside a book, like let's say you're looking inside a book like this one. This is a situation like this here. You have your V. You have your B down here. Here's your B. Also your B is down here. You have your A is there. Right? And you have your D is there in the corner there. So these two, and then you have your C somewhere maybe here. Here's your C. So this is a situation like this. Let me join these two. What you can see, the 3D view of it is a situation like this one here. All these points are sitting like this. All of them. That's what I was trying to demonstrate. So here's your A, here's your B, here's your C. They're sitting like this. You can see that this book is coming out towards me, and your D is sitting there in the corner. So I'm saying we have 3 triangles. You have the triangle at the base, we have this second one, this one here, and you have third one there. The fourth one is this one here, the big one, this one. So this is BDC, this one, BABD, ABD. That's a fourth triangle. So we have 4 triangles there. And if you want to draw a fourth triangle separately, it looks like this. You'll have this side, which is this, and you have a navy side, which is that. There is it, which is this, and then you'll have an orange side, and orange side look like this one. So this is the triangle that you can see. So say you have A, you have B here, and you have what? You have D at the top. There is D at the top there. What do you know in this triangle? On this triangle, you don't know much. You only know 20, which is this length over here, which is this one. This is just 20 units. I don't think you know anything else here. I don't see anything else that you can know from this triangle. Because you don't have the side, you don't have the side, you don't have the side. And you don't have the angles as well. You only know that side, which is 20 units. So I'm done with this. So let's get on with the question. I was just analyzing the first part. So, question number 1 is 7.1.1. I'm going to use a navy color, or the blue one. 7.1.1. What are they saying in 7.1.1? They are saying calculate the length of AC. So they want us to find the length of what? Of AC. Where is AC? AC is this length here. This length here. That is AC. If you're looking at AC, AC is on two triangles, right? It's on the orange triangle, which you can see here, and on the blue triangle, which is this one here. So the orange triangle is ABC. The base triangle, ABC, here is it. The blue triangle is ACD. Is this triangle over here? This is the blue triangle. No problem. So, on the orange triangle, you only have two measurements. You have the angle, right? And this side over here, which is 8 units. That is shared with the red triangle. So, you know that on the orange triangle, you have 8 units, which is this, which is BC. And you have this angle here. So, in this case, this information is not enough to find the side that you want, which is this side. Right? Because you can't use the sine rule, you can use the cosine rule. So, but if you're looking at this triangle here, the blue triangle, you have a right angle triangle. Your right angle triangle looks like this. Looks like this one here. The blue triangle. So you know we have 30, we have 20 units. This is C, this is A, and this is, oh sorry, this is D on top. This is D, this is A. So you want AC, and you know this is 90 degrees, right? So you know very well, if this is 90 degrees on a right angle triangle with one side and one angle, you can use trig ratios to find the side that you are interested in, right? No problem. So we have this side, 20 is our hypotenuse, right? Because the angle is the side opposite our biggest right angle, right? So that is our hypotenuse. And we want the adjacent side, right? So it's more like we have our hypotenuse and we want the adjacent side. You know which trig ratio that relates the hypotenuse and the adjacent side. The hypotenuse and the adjacent side are related by the cosine trig ratio. So you know cosine of angle A will be equal to adjacent side, right? Adjacent side over the hypotenuse side. The adjacent side is this one, which is what? Which is AC over the hypotenuse side, which is what? Which is 20. Oh, let me not say 20, which is 80. No problem. So you get that your cosine of angle A is equal to AC divided by AD. That's what you have. Right? So you substitute now. So cosine of 30 degrees is equal to AC, which is what you're looking for, divided by AD, which is 20. Therefore, your AC is equal to 20 cos 30 degrees. Right? Which is equal to AC, is equal to the answer to that. 20 times cosine of 30 degrees. That's what you should be looking for. So you're saying 20 cosine of 30 degrees. You get that your distance or your length is equal to 10 square root of 3 or maybe you can say it's 17.32 units. Done. We're done with 7.1.1. Let's go to the next one, 7.1.2. So we found this information. Let's put it here. So we have this length here to be what? To be 10 root 3. This is AC. So we have this length now, AC. No problem. What are they saying at 7.1.2? At 7.1.2, they are saying calculate the length of AB. They want us to find the length of AB. Where is AB? AB is this length over here. They want us to find that length over there. So how do we do that? Well, we can say, let's draw this triangle that contains AB. It's the orange triangle. So let's try to draw this orange triangle again. So the orange triangle, the base one. So here is it. It looks like this. So you have your A, you have B, and you have C. You have this length that is, this angle is 100 degrees. And you have AC, which you calculated there, to be 10 root 3. And you have this length that you're given to be 8 units. That's what you're given, right? What do they want you to find? They want you to find AB. So what do you have? You have a side, an included angle, and a side. You have a side, included angle, and a side. So if you have a side, included angle, and a side, what do? You use the cosine rule. This is a perfect condition for a cosine rule. So you have a side, included angle, and a side. That's why cosine rule works the best. When you have a side, and included angle, and a side. Side, angle, side. That's what they say. So what do you say? What is our cosine rule? So this is a small c here. This is angle A, the side opposite angle A is small a. This is angle B, the side opposite B is small b. So you want this c here, the small c. So your c squared is equal to the sum of the including sides, which the sum of the square of the including sides, which is a squared plus b squared minus 2ab cosine of angle C, right? What is your angle? What is your angle C? What is C squared? It's AB, which is what you're looking for. This C side is the side AB. So AB squared. AB squared is equal to A squared. Where is A? Small a. Where is angle A is here? Small a is that side, which is BC squared. Plus, where is B? Angle B, small b should be opposite. So it's AC, which is AC squared minus 2 BC AC cosine of angle C. Let's substitute now. What is your A? B squared, which is what you're looking for. So your AB squared will stay as is. It's called your BC squared. What is your BC? It's that one, or it's this one here, which is 8 all squared plus 10 root 3 all squared minus 2 into 8, 10 root 3 cosine of angle C. What is angle C? It's 100 degrees. Therefore, your AB squared is equal to the answer to this thing. Let's punch it straightforward, this one. I like it. So it's 8 all squared plus 10 root 3 all squared, right? Minus 2 into 8 all 8 times 10 root 3 cosine of 100 degrees. Right? Cosine of 100 degrees. What do we get? We get that your AB squared is equal to 412, right? 0.12. Then you take your square root, so your AB is equal to the answer of that. Square root of that. What is the answer? Get that your answer is 20.3. So your AC, your AB is equal to 20.3. Where is AB? AB is this one. It's 20.3 units. So you can put it back here. It's 20.3 units, which is the same as this one here. It's 20.3 units. Done. We have this. So let's go. We'll go to the next question, which I believe is the last one. What are they saying? They are saying to us now, it is further given that angle B between AB and BD is equal to 73.4. Calculate angle D, which is the angle between AD and BD. Let's go to this diagram of ours. They are saying it is further given that angle B between AB and BD is equal to 73.4. Calculate the size of angle D, the angle between AD and DB. So they're saying angle B, which is this angle here, between AB, which is between AB and BD, which is this angle here. The angle here, between AB and BD. We are given that this angle here is equal to what? 73.4, which is the same as this angle here. The angle between AB and BD is 73.4, is it? Because this triangle is the big triangle, the face of the triangle. No problem. So they want us to find angle D. So they want us to find angle D, the angle between AD and DB, which is they want us to find this angle here. That's the angle that they want us to find. So I'll draw this triangle over there. Because if you look at it, D is that one there, A is that angle there, and B is this angle here. So this angle here is the angle between AB and DB. That's what they have given us. So they want us to find this angle over there. So I'll say, okay, let's redraw the triangle and make it, I don't know, I don't want to redraw it. Let me not redraw it. So on this triangle, what do we have? We have an angle and the opposite side, right? And then a side and the angle opposite it. That's what we're trying to find. We're trying to find this angle here. We want to find this angle, but we have this opposite side, and we have this angle and this opposite side. This is a perfect condition for a sine rule, because you use a sine rule mostly. It works very perfectly when you have an angle and its opposite side, and you are missing a side, but having its opposite angle, and vice versa. So in this case, we'll say, okay, this is small d, this one, and this is small a here, and this is small b. So you know sine rule very well. So we want to use this side and that side. So it's going to be sine b, sine angle b over sine b. So it's going to be sine of angle b over the side b is equal to what? Sine of angle d over small d, which is sine of angle d over the side d. And then you substitute from there. What is sine of angle b? Sine of angle b. What is angle b? Your angle b is 73.4, right? 73.4. Divided by side b. The side b is the side opposite b, which is 20 units. Is equal to sine angle d. What is sine angle d? Sine angle d is what we're looking for. So sine angle d is what we're trying to find. Divided by length of opposite angle d, which is 20.3. 20.3. And you solve. So you get that cross multiply. At the end, you will say this times this, so it will be 20.3 sine 73.4, right? Is equal to 20. This times that 20 sine angle d. Then divide by 20. We divide by 20. So this and that go away. You get that your sine of angle d is equal to the answer to that. So let's go and find the answer to that. See what we get. Where's the calculator? Oh, here's it. So 20.3 sine 73.4 all divided by 20. Oh. you get that this is 0.97. So your angle D is equal to arc sine 0.97. So your angle D is equal to arc sine 0.97. Get that your angle is equal to 70. Angle D is equal to what? 76.58. That's where your angle D is on. You can say therefore your ADB is equal to 76.58 degrees. And you're done with question 7. Straightforward. This was the nicest I've seen in a very long time. And I hope it does make sense to you as it does to me. Thank you for watching. Cheers.